Okay, welcome to my video on the effect that changing one attribute has on surface area. Now, previously in this unit, we looked at what effect it has on volume. And this first example, we're going to be doubling and seeing what happens to the surface area. To recall what we did when we did volume, if we doubled the length and only the length, then the volume doubled. If we doubled only the width, then the volume doubled. If we doubled only the height, then the volume doubled. And now we're going to learn, does that have the same effect on surface area? So let's find out. Now the original prism here has a length of 3 centimeters, a width of 4 centimeters, and a height of 2 centimeters. So if we double the length, the new length will become 6 centimeters because 3 times 2 is 6. For letter C, if we double now the width, the original width is 4, and 4 times 2 is 8. So 8 centimeters is the new width. And for letter D, if we multiply the height by 2 or double it, 2 times 2 is 4. So it would become 4 centimeters. Now, what we're going to do is, since there's 4 here, and we've done a lot of practice in class, I'm only going to make you do one of them. So just go ahead and down below in the workspace, write the letter A and find the surface area for letter A. And after I write the formula, you can pause the video and work it out and then turn it back on to make sure you did A correctly. And then I will give you the surface area for B, C, and D. So look down at the bottom and I wanted you to do letter A. So go ahead and pause the video and work out letter A after I write the formula. So SA equals 2LW plus 2LH plus 2WH. Okay, now you can pause the video. I know I said it 100 times already, but now you can really pause the video and work out the rest. So just look at the chart, find the length, the width, and the height for letter A. Okay, welcome back if you paused the video. And let's see how you did. So 2 times length times width, so the length is 3 and the width is 4. So I write 2 times 3 times 4 plus 2 times length times height, so the length is 3 and the height was 2 plus 2 times width times height, and the width was 4 and the height was 2. Now, just like we learned previously, we're going to go ahead and box in each part. And to remember or to recall what we learned previously, the length and the width represents the top, the length and the height represents the side, and the width and the height the width and the height represents the side, the length and the height represents the front. I don't know why I keep mixing that up. Okay, so top, front, side. And the reason why we're doubling is because there's a top and a bottom, a front and a back, and a side and a side. Okay, so 2 times 3 times 4 is 24, plus 2 times 3 times 2 is 12, plus 2 times 4 times 2 is 16. Add them all up, and you should have got 52 centimeters squared. Okay, now look back up at the top, and we're going to fill out the chart. I'm not going to have you calculate all 4. I've actually done that for you. So let's fill out the chart. You just did A, so that was 52 centimeters squared. Okay, B is 88 centimeters squared. C is 92 centimeters squared. And D is 80 centimeters squared. So it wants us to compare the surface area of your original prism to the surface area of the new prisms and explain how changing attributes affects surface area. So let's look at this for a second. When we learned about volume, we said that if you double one of the attributes, which we did in B, we doubled one in C, and we doubled one in D, that the volume would double. But does surface area double? And the answer is no, because if I doubled 52, I would get 104. Are any of these 104? No. But do they all go up? Yes. 52 to 88 it went up by 36. 52 to 92, it went up by 40. And 52 to 80, it went up by 28. Now, do they all go up by the same amount? No. So here's what we're going to say. And write this down as I do. All of the surface areas increased but did not double like each of the attributes did. Okay, now, did we apply a scale factor? Yes, we applied a scale factor. But did the scale factor have the same effect that it had on the attribute as it had on the surface area? The answer is no, because it didn't double. Okay? We doubled the length, the width, and the height, but none of them made the surface area double. Okay, let's look at the back where we're going to look at if the scale factor is a fraction. So turn the page to the back. And we're going to do the same thing. We're going to do the chart. You're going to find the surface area for letter A only. And then we're going to do the exact same thing. So the original prism has a length of 6, a width of 4, and a height of 2. So if we cut the length in half, we get 3 centimeters. If we cut the width in half, we get 2 centimeters. And if we cut the height in half, we get 1 centimeter. Okay, so go ahead down to the workspace and write the letter A. And of course, write the formula. So surface area equals 2LW plus 2LH plus 2WH. Now we're going to look at the chart and figure out what our length, width, and height is. So the first part is 2LW. So we're going to write 2 times 6 times 4. And remember, once again, this represents the top. And then we're going to do 2LH, so 2 times 6 times 2. And we're going to box this in. And of course, remember, that's the front. And also represents the back. And this represents the top and the bottom because we're doubling it. And then the last part, 2WH, so 2 times 4 times 2. Box it in. Now, we're going to multiply, so 2 times 6 times 4 is 48, plus 2 times 6 times 2 is 24, plus 2 times 4 times 2 is 16. When I add all of that up, I get 88 centimeters squared, because area always has a label of squared or an exponent of 2. Okay, so let's go back up and complete the chart. And of course, we know what the surface area of A is. So we're going to fill that in. So the surface area of A is 88 centimeters squared. The surface area of B, which I didn't have you figure out, is 52 centimeters squared. C is 56 centimeters squared. And D is 68 centimeters squared. So now it asks us to compare the surface area of the original prism to the surface area of the new prisms and explain how changing an attribute affects surface area. So when we did volume, when it had a scale factor of 1/2, we just cut the volume in half. So half of 88 would be 44. Now, are any of these surface areas 44? No. So it does not have the same effect as volume. But what we can do is see if it increased or decreased, and this looks like it went down by 36. This one went down by 32, and then the last one went down by 20. So here's what we're going to write. All of the surface areas decreased but did not half like each of the attributes. So we can multiply the attributes, length, width, or height, by a scale factor, but it's not going to have the same effect as volume. It will either increase or decrease, but not by that scale factor. So like this one decreased, but not by 1/2. So does scale factor apply to surface area? The answer is no. It does not apply to surface area because when I double or half it, the surface area does not double or half. It increases or decreases, but it does not double or half. So that's why we say that the scale factor does not apply to surface area. So that concludes our notes on changing one attribute for the surface area. Now you can complete the rest of your work. Have a great day.